The soldering methods that are presented in this demonstration video are being applied to flexible stainless steel conduit assemblies. For our first method, we are using what could be considered a type of solder preform. This is accomplished by wrapping a rosin core solder wire around the conduit sleeve and pressing it into the fluted channels using needle nose pliers. This will regulate the amount of solder that's being used and helps to improve the depth and level of solder saturation that takes place within the joint. The amount or length of solder wire to apply to the conduit can be determined by the depth of the end connector that will be attached. The solder wire will be trimmed flush with the end of the conduit, and we will be ready to perform our soldering application. If you look closely at this setup, you'll see that I've already got solder wound around the conduit, and this is going to be the first assembly we're going to solder together. This particular portion of our application helps us to demonstrate that when a deeper thermal penetration may be required to overcome a greater mass or wall thickness, it may be necessary to pulse or cycle the power supply as shown here to eliminate the possibility of overheating the contact surface while providing adequate thermal saturation into the joint where it is needed. Using the same pulsing technique and preform method, we solder a smaller end connector to the conduit sleeve. Watch the preform as heat activates the flux and melts the solder, which is then drawn deeply into the joint by the capillary action that is now taking place. This next soldering method we present is considered pre-filling. We begin by applying a small amount of liquid flux to the inner wall of the small end connector and placing the connector into our makeshift soldering fixture. The next step is to apply heat to the end connector, bringing it to a sufficient temperature to activate the liquid flux and then to melt and flow the solder. The equipment used for each of the soldering applications performed in this demonstration video is an American Beauty Model 10507 resistance soldering system. With a small amount of solder melted inside of the connector, we can now introduce the conduit sleeve. And as we continue heating the connector, the thermal energy passes through the molten solder to the conduit, heating its surface to the point that solder will wet to it, completing our demonstration of this soldering method. The final soldering method that is being demonstrated for this particular application is based upon the use of solder paste. This should not be confused with paste flux, which does not contain any solder. Unlike pre-tinning and pre-filling methods, using the preforms or solder paste method does not generally require a separate heating cycle prior to the actual soldering process. A precise amount of solder paste is being applied in a controlled manner to the inner walls of the small end connector. And next, solder is applied directly into the thin fluted channels of the flexible conduit sleeve. The syringe type applicator that is being used to dispense the solder paste accepts a variety of interchangeable tip sizes, allowing us to tightly control the distribution of the solder to the location desired. With solder paste applied to the mating surface of both components, they can be assembled together and are now ready for the final soldering process. With the run light showing the actual duration that power is being applied, you can see that the solder paste melts and flows in about 12 seconds. We hope that the three soldering methods presented in this application video have shown how American Beauty might provide solutions for some of your difficult soldering needs.